The performance capabilities of modern tactical military aircraft have placed new demands on the training commands of those employing new generation supersonic multi-purpose jet aircraft. Pilots must now operate complex fire control systems and conduct precision flying maneuvers under the pressures of combat situations. The ability to function with precision during the fleeting moments of air combat requires high levels of flying proficiency be obtained during training and maintained during the pilot's operational career. Efficient training for such pilots is complicated by factors such as economics, since high operating costs of complex military aircraft and worldwide fuel shortages have reduced training flight time allotments in most military flying units. At Beech Aircraft Corporation, it was determined that such problems could be solved by the development of a low-cost tactical training substitute. Beech Aircraft in 1977 began testing an advanced development of its new turboprop Navy T34C. Designated the T34C-1, the aircraft incorporated provisions for external stores, increased engine power, and increased gross weight capabilities. This aircraft is intended to provide a low-cost airplane for weapons delivery and air combat tactical training. The T34C-1 is able to perform these tasks with no compromising of the basic training capabilities provided in the U.S. Navy T34C. Increasing the engine power to 550 horsepower from the 400 horsepower rating in the Navy T34C has permitted the aircraft to retain its excellent performance at a gross weight of 5,500 pounds, 1,200 pounds above the maximum weight of the U.S. Navy T34C. The T34C-1 has provisions for carrying up to 1,200 pounds of external stores. These may be training dispensers, bombs, rocket pods, gun pods, or other miscellaneous stores, such as flare dispensers, supply canisters, and life rafts, etc. The T34C-1 was designed using a systems approach and incorporates a modern armament control system to integrate the gun sight and gun camera with the individual weapons to be mounted on the aircraft. The T34C-1 armament control system utilizes a variety of safety features, permitting the low-time pilot to safely undertake armament training missions. For example, each pylon incorporates a bomb release disable switch, which can be set up to prevent the pilot from inadvertently releasing a high-value store using the bombing mode. This switch does not affect the emergency jettison features. Both electrical and manual jettison features are provided with the T34C-1 armament system. By early 1977, the T34C-1 development had proceeded through a series of ground tests, which qualified the new configuration. In June 1977, Beech Aircraft began testing an advanced version of the turbine-powered T34C airplane. Designated the T34C-1, this higher-powered version was developed for use as a weapons delivery trainer. The prototype, serial number GM1, is shown here making its first flight with external stores installed. The ability of the airplane to carry a large variety of training-type ordnance was soon demonstrated during the intensive flight test which followed. Performance and handling trials soon verified that this new version of the T-34C was an outstanding airplane. A series of tests were performed to demonstrate the ability to jettison external stores in emergency situations. The gun pod is shown being dropped in this sequence. Prior to firing the 7.62 millimeter minigun pod, this weapon was tested on the ground. This door permits the aircraft to perform gunnery training using the inexpensive 7.62 millimeter NATO ammunition. Measurements taken during the ground firings demonstrated the basic compatibility of the T-34C airplane and the minigun. Recoil forces were light and accuracy high. The spent shell cases are ejected from the bottom of the pod during firing. Prior to the airborne firing tests, the gun pod was bore-sighted and aligned with the aircraft's optical sighting system. Ammunition, linked in a standard NATO mix of tracer and ball ammunition, was loaded into the gun pod using an integral crank-type loader. Depending on the ground setting, the minigun can selectively fire at a rate of 100 or 50 rounds per second. The aircraft fire control system has provisions for the gun pods on both inboard pylons. After final checks, the T-34C is launched for the first airborne firing tests. At the desert test site, the range crew awaits the arrival of the test aircraft. Final wind measurements and range conditions are relayed to the pilot. When the test range has been cleared, the T-34C maneuvers for the first firing run. Dive angles and firing speeds have been selected to demonstrate the entire firing envelope of the aircraft. Guns are fired both singly and in pairs to test all possible combinations. The gun sight settings have been determined from computer-generated ballistic tables developed for the T-34C-1 aircraft. No problems were encountered during any of the firing runs. The empty shell cases ejected well clear of the aircraft, and no muzzle blast effects or adverse trim changes were encountered during the firing. The ease with which the pilot is able to acquire, track, and hold the target aiming point during the firing runs demonstrates the basic good handling characteristics of the T-34C airplane. No adverse conditions were noted during these tests, which covered a range of dive angles, firing combinations, and dive speeds up to the limiting red line airspeed. The gun sight provides an accurate aiming reference. Computer-generated ballistic tables were shown to match the actual firing conditions. Over 3,000 rounds of ammunition were fired during the airborne firing tests. The maneuverability of the nimble T-34C permits the aircraft to fire safely at much lower altitudes than would be permitted for more sophisticated jet-powered training airplanes. At a different location, rocket tests were conducted. Standard 2.75-inch practice rockets were loaded into the 7-tube LAU-68 rocket launchers. These permit the aircraft to carry a total of 28 rockets if all 4 pods are installed. As a last step in the loading sequence, the launchers are electrically connected to the fire control system. Test pilot Jim Dolby straps in. The engine is started and ground safety pins are removed to arm the rockets prior to launching the aircraft, which is flown to the offshore test range. Other aircraft and shipping have been previously cleared from the test area. Both single and multiple firings were conducted over a wide range of dive angles and firing speeds. The Turbine Mentor again proved to be a stable launching platform and an ideal classroom for performing the armament training task. After the rocket firings, practice bomb dispensers were installed to test the ability to perform dive bombing training using small 25-pound practice bombs. Each dispenser holds 4 bomblets. Dive bombing at angles up to 70 degrees proved to be no problem for the versatile T-34C-1. Bomb separation was clean at all speeds and dive angles. At a desert test site, larger 250-pound sand-filled practice bombs were tested. By this time, test pilot Dolby has developed complete confidence in the airplane and its ability to accurately deliver the ordnance within the narrow target impact area. Both single and multiple drops were performed at selected airspeeds and dive angles to test the most severe release conditions. No adverse characteristics were noted, and all the bombs separated from the racks without any tendency to oscillate or behave erratically. The impact points were measured to verify the ballistic tables which have been developed for the airplane. The next tests in the series were performed to demonstrate the airplane as a target towing vehicle. Targets are towed directly from the bomb racks without any special adapters. This permits the target and line to be released using the normal bomb release or jettison system. Both banner and sleeve targets were towed and released. Targets may be towed on a line over 1,000 feet long for air-to-air firing practice. Thus, the T-34C can tow the targets for other T-34C aircraft during gunnery practice missions. The Turbine Mentor can also carry and launch the more sophisticated tow targets with light, radar, or infrared augmentation. These targets are deployed in flight and jettisoned at the end of the mission. They're towed with up to 8,000 feet of small diameter wire. The radar-augmented TRX-3 target is shown being launched in this sequence. The ability of the T34C-1 to carry a wide range of stores is demonstrated in this configuration. The aircraft was loaded with 16 night illumination flares. These were launched at night under operational conditions to evaluate cockpit lighting, glare, and other aspects of this application. The Turbine Mentor has proven to be a versatile, low-cost aerial platform, capable of performing many types of training and operational missions. All this is in addition to being an outstanding pilot training airplane. Each aircraft has built into the T-34C the ability to adapt the aircraft to handle new advanced weapons systems as they are developed. A gun camera system permits some weapons training using film instead of live ordnance. The film is marked to indicate the simulated firing event. Air combat maneuver training may be ideally performed in the T-34C, which possesses outstanding aerobatic performance and control responses very similar to those of advanced jet fighter aircraft. The T-34C and T-34C-1 have now been accepted by the Air Forces and Navies of many countries. Each aircraft is proud to have made this contribution to the operational readiness and defenses of the United States and our friends throughout the world. Just as the older piston-powered Mentor set the standard for trainers in the 1950s, the new turbine-powered Mentor has set a new standard for military training airplanes.